Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Abdul Haq. I'm representative of my research team. The first author is Khairul Anwar, and me as second author, and then Iwan Kurnianto Wibowo and Muhammad Mubed Bahtiar. The title of our research is GPU Parallel Computing for Detection and Classification Object and Robot Software ERSOW. So this is the background problem of our research. Object detection and classification as important process to provide main data source to all further action like control, navigation, and localization system. But this process takes longer computation time. High-speed object detection and classification process needs to avoid serious problem on ERSOW autonomous mobile robot. This is the GPU implementation. Our works on object detection and classification use deep neural networks by NVIDIA GPU parallel computing. By using transfer learning, we can use different hosts for training and inference phase. This is the flow of the GPU implementation. There are camera input, and then this is the NVIDIA Jetson. And then this is the specification of the NVIDIA Jetson that we use, etc. So this is the DetectNet overview, and the DetectNet is model architecture from NVIDIA DKITs and trained using Caffe deep learning framework. DetectNet using three-dimensional label includes coordinate from top left to bottom right, and also classes of objects, represented by grid square overlay in image. And there are also 5. The first is data layer ingests image and labels, and former layer applies online augmentation. And number 2 is FC and performs future extraction and predict class of object. The third is loss function measure the error of two tasks. There are predict object coverage and object bounding box corner per grid square. And clustering function produces a set of the bounding box during validation, and mean average value is computed to measure model performance against new value. So this is the result and analysis during training progress. Increasing the number of epochs as one of training process will increase the accuracy value represented by mean average value. Epoch control, how many the learning algorithm doing an iteration on training dataset until neural network model could achieve minimum difference between prediction and training output. We have class robot don't care. We have to about 438 in training and 40 in validation, and the mean average value is 53%. And pre-trained model gained more speed because it's accumulated with many previous training model and process. It was very different with new custom model which we have trained recently. In the custom model, we got 32 FPS in one class object, and then with pre-trained model SSD MobileNet version 2, we got 99 frames per second, and the object class is not just only one. There are 91 class objects with the same frame size. You can see this is the result. We can detect the robot, and we can also detect the ball. We use some reference from this paper or publication. And the end of the presentation. Thanks for attention. Wassalamualaikum warahmatullahi wabarakatuh.